Let's consider this example of our block of a mass of 10 kilograms. Let's say we don't know what is inside. First, let's try to calculate the normal force. What is the normal force in this case? Let's identify the forces acting on my block. One is its weight. The other one is the normal force. There are only these two forces. And we know that the normal force and the weight, the force due to gravity, they should sum up to give 0 because our box is not accelerating. The net force should be 0. But this tells me that the normal force has a magnitude equal to the weight of the object, which is 10 kilograms multiplied by 9.8 meters per second squared, or 98 newtons. So in this case, the normal force acting on the block by our table is just 98 newtons. Let's modify it slightly now. Let's say that you push this box downward with a force equal to 40 newtons. You see there is this additional force acting on the block. Let's call that F prime. And that is 40 newtons. The magnitude is 40 newtons. What will be the normal force in this case? Again, if we consider the sum of the forces acting on our block, there is the normal force acting on our block. There is its force due to gravity, plus there is also this additional force now. They should sum up to give 0. But this tells us that the magnitude of the forces pushing it downward, which is F prime, this is pushing it downward. The weight is pushing it downward, which is 98 newtons. It should be equal to the magnitude of the total forces pushing it upward, which is the only force pushing the block upward is the normal force. Now we know that this F prime, you are pushing it with 40 newtons. So we find that the normal force in this case is 138 newtons. So you see that this is an example where the normal force acting on a block has a magnitude that is different than its weight. Remember, the box has a weight of 98 newtons, whereas due to this additional force, the normal force is 138 newtons. Now, what happens if this new force, you are not pushing it down, but through a rope, you are just pulling it up by 40 newtons? In this case, you are exerting a force in the upward direction. Again, the reasoning will be the same. The total force acting on our object should be 0. So the sum of the magnitudes of the forces in the upward direction, in this case the normal force, plus F prime, 40 newtons. This should be equal to the sum of the forces pushing it down, the magnitudes of the forces pushing it downward, which is the weight. So it's 98 newtons. So which tells us that in this case, the normal force is 58 newtons. So you see that the normal force acting on an object can be equal to its weight, larger than its weight, or smaller than its weight. And this is mainly because the weight and the normal force are not action-reaction pairs.